In this video, we're going to talk about division of fractions. Now, there are some numbers or a special number that we're expert in dividing by. 2/3 divided by 1 is 2/3. The reason is 1 times 2/3 does equal to 2/3. 7 divided by 1 is 7. 5/8 divided by 1 is just 5/8. 2 to the 17th, whatever that number is, when you divide it by 1, you get 2 to the 17th. We're really good in dividing by 1. So there's a hint that we're going to want to divide by 1. Now, what do you multiply 2/3 by to get back 1? Well, you want to cancel out the 2, so you put a 2 in the bottom, so that reduces to 1, and you want to cancel out that 3 on the bottom, so you put a 3 on the top, and then you get 1. That is, what do you multiply 2/3 by to get 1? 3/2. Let's look at this a little bit closer. Now, I'm not saying you don't know what 2 times 3 is, but let's suppose they were bigger numbers. Whatever 2 times 3 is, it's the same as 3 times 2. And if the numerator and the denominator are the same, you get 1. If you have 72 divided by 1249, what do you multiply it by to get back 1? Well, if you multiply by the reciprocal of this number, let's see, the top is going to be 72 times 749. The top is going to be 72 times 1249. The bottom is going to be 1249 times 72. But they're equal. That is, when you multiply the 2 top numbers and the 2 bottom numbers, no matter, we may not know what we get, but we know the numerator and denominator will be the same. That means the fraction equals 0. If you have 7/13, what do you multiply it by to get 1? The answer is that number flipped over. You may not know what 7 times 13 is. You may not know what 13 times 7 is, but they're the same answer. They happen to both be 91. And 91 divided by 91 is 1. If you have any fraction where the a and b are not 0, and you multiply by the reciprocal, the numerator is going to be ab, the bottom is going to be ba, but ba is the same as ab, you get 1. We're dividing by the same 2 numbers. Whatever a times b is, whether it's 90 or 13, a times b is going to be the same number in the bottom. You can't multiply 72 and 1249 on the top and multiply 72 and 1249 in the bottom and get different answers. If you did, you have at least one mistake. But if you do the multiplication correctly, you have to get the same answer. And when you divide the same 2 numbers, you generally get 1. The only time you don't get 1 is if you have 0/0. And it's kind of obvious, I hope, that 72 times 1249 is not 0. Because if you multiply 2 numbers and they multiply out to 0, then one of those numbers, if not both of them, were 0. Okay, so now we're experts with dividing by 1. Any number divided by 1 is that number. So now, if you have 2/3 over 7/13. I want to change the way this looks. I want to get a 1 in the bottom. Okay, so what I'm going to do is, so now this, let me write it slightly different like I usually do. That fraction, friendly or not, doesn't matter. That fraction is equal to itself times 1. But I want to get a 1 in the denominator. So what do I multiply 7 over 13 by? 13 over 7. Now, if this fraction has any pair of equaling 1, whatever is in the denominator has to be in the numerator. So the numerator is 2/3 times 13 over 7 over 1. But dividing by 1 doesn't really do anything. So looks like 26 over 21. That is the answer to this one. Let's look at another problem. Suppose you had 2/3. Sorry. How about no more 2/3 for now. Suppose you have 5/6 and you want to divide this by 7/15. I want to change the way it looks. I don't want to be dividing one fraction by another fraction. That means I want to multiply this by 1. Now, if the denominator became 1, that would be beautiful. So I'm going to multiply by 15 over 7 because I know one thing. This times this is 1. So I have to do the same to the numerator. So I get 5 over 6 times 15 over 7. And the rule for dividing by 1 is don't bother. 5 times, 3 goes into both of these numbers, 2 and 5 times. 5 times 5 is 25. 2 times 7 is 14. There's your answer. You want to say it's 1 and 11 left over, 1 and 11/25, fine. Now, since they give you fractions, you can, unless stated otherwise, say on an exam, you can give back fractions. I would reduce the fractions. So you don't have to use mixed numbers. You can if you like. Suppose you had 4/7 divided by 9/2. Oh boy, do I want to change the way this looks. That's code for I want to multiply by 1. I want to multiply that number by 2/9 and the top also by 2/9. When I multiply the two bottom numbers, I get 1 by design. And the top is whatever 4/7 times 2/9 is. And the rule for dividing by 1 is don't bother. I do not see any cancellation going on. Okay. Now, let us look more closely at the results we've been getting. Let us look more closely. To calculate this problem right here, we ultimately did this problem. And if you notice, the 2/3 stayed the same. Division became multiplication. And the bottom number got flipped over. We kept the top number. So reading from top to bottom. We changed the sign, and we flipped the bottom number. Let me not say kept. You keep. You keep, change, and flip. I kept the top number. Here it is. I changed division to multiplication, and I flipped the bottom number to 13 over 7. Now, let's look at the next one. Other than reducing, we ended up with 5 6 times 15 sevenths. Oh, look at this. We kept the top number, we changed division to multiplication, and we flipped over the second number. And then we reduced. Next problem. We should keep the top number. We changed division to multiplication, and the bottom number got flipped over. Okay, I don't think I should just tell you the rule. You need to see why. For example, if you have A over B in general divided by C over D, with no question about it, it equals itself times 1. Well, the way I want to write 1 is in the bottom, I want D over C. Because, I don't even know what C times D is. But you know what? It's the same as D times C. That bottom is now going to be 1. But for this fraction to be 1, because this, that number is equal to itself times 1. So what's in here has to be 1. And I really, really want that denominator to be D over C. So I make the numerator D over C. Now that fraction is 1. So to get the numerator, it's A over B times D over C. All over 1. But the rule for dividing by 1 is don't. Just keep the denominator. And if we look really closely, look at this. We kept the top number. We changed division to multiplication, and we flipped over the bottom number. That is the rule. Not because your teacher told you, not because I told you, not because your uncle may have told you, but because we derived it. We proved it. It really is. This really does become that. And all I did was multiply by 1. That's all I did. I took the problem that I was given and I multiplied by 1 in a way where the denominator became 1. I just multiplied by the reciprocal of this. So now the denominator is 1, which means we could ignore it. But again, I have to multiply by 1. And if the bottom is D over C, the top has to be D over C. So the final answer is just going to be this times that. There it is. There it is, even bigger. You keep the numerator, you change division to multiplication, and you flip the second number. Now, I want to be very clear. Many teachers, they don't show this. A over B divided by C over D. This equals to A over B times D over C. A over B times D over C. But we're only talking about usually going from here to there. But equality works the other way. You can go from this to that. Keep the first, change division, that's multiplication, change division to multiplication, and did I say it wrong again? Change multiplication to division and flip over the second number. For example, if you have 7/3 times 2/5, you can say, I'm going to keep the top number, the first number. I'm going to change multiplication to division, and I am going to flip it over. I'm going to flip over the 2/5. You can go one way to another way, and there will be times you want that. You may have a formula that's in the that says you have to divide A and B. You have to divide A and B. And they give you 7/3 times 2/5. But you have to write it as a fraction. You need to decide what A and B are. Well, you keep this, you change multiplication to division, and you flip over the bottom number. Ah, that's A, there's my division line, and that's B. Okay, you can convert both ways. It's not just one way. Equality works both ways. You can go from this form back to this form, or you can go from the left form to the right form. They come hand in hand. Now, there's one last thing I want to talk about. I used it all over the place, but there's something called the main division line. Well, first I want to do problems like this first. Suppose you have 14/6 divided by 7. This is saying you have 14 or something. You have 14/6. Make believe there's 1/6 of a dollar bill, okay? Be open-minded. Don't be brainwashed and say, what are you talking about? There's only $1 bills and $5 bills and $10 bills and 20s. How many of you know that there's a $2 bill? Then you're dividing by 7. This is 2/16. If you have 14 of those bills and you share it with 7 people, a total of 7 people, each person's going to get 2 of those. 2 of those $6. $16. Okay? And it turns out that this is 2/6 or 1/3. That is, 2 goes in both of those numbers 1 and 3 times. So, if you have 6/7 and you want to divide it by 3, you could just divide the 6 by the 3 and get 2/7. If you don't believe that, wonderful. Wonderful. Don't believe it, let's show it. It's the top number we keep. We change division to multiplication, and this bottom number 3 is 3/1, so I get to multiply by 1/3. So basically, yeah, we're dividing the 6 by the 3. 3 goes into 6 2 times. We get 2/7. Okay, if you had 12/21 and you're going to divide it by 3, you're going to get 4/21. If you don't believe it, you keep the first fraction, you change division to multiplication, and this 3 you flip over. And yes, 3 goes into 12 4 times. So you end up with 4 times 1 over, if you like, 21 times 1. Basically, if you have A over B and you divide this by C, I keep, I change, and this C over 1, I flip. So basically, it's A over C over B. And this works nicely if C goes into A. Okay? If this were 8 and this were 16, then it goes in. So A over C would be 2. Now, I agree if C doesn't go into A, this doesn't work so nicely. Now, the last thing I want to talk about is what's called the main division line. Suppose you have this problem. 100 divided by 2 divided by 5. One of those division lines is a bit longer. This one here. It is this number divided by that number. That top number is 50. 100 divided by 2 is 50. I don't know why I'm doing this because it's ridiculous. So I apologize. Suppose you have 100 divided by 10 divided by 2. So it is this number divided by this number. Now the first number happens to be its own fraction. 100 divided by 10 is 10. Divided by 2 is 5. Now, what if I write the same three numbers in the same order? But I make this the main division line. So it is this number divided by that number. Before I can do the divisions, I need to know what the numbers are. The top number is 100. 10 divided by 2 is 5. So the bottom number is 5. This is 20. Notice I didn't get the same answer. The main division line is very important. That's why I would write things like 2/3 divided by 5/7. I always put the main division line longer. So we keep, we change, and we flip. And you get 14 over 15. Okay, but if you had 2 divided by 3 divided by 5 versus 2 divided by 3/5, you will not get the same answer. Here is the main division line. It's that number, keep it, change division to multiplication, and this is 5 over 1, so flip it. 2 times 1, 3 times 5, 2/15. Over here, that's the main division line. We keep it, we change division to multiplication, and we flip over the second number, and we get 10/3. They're not equal. They're not equal. Is somebody, remember please that 100 divided by 10 over 2 is not the same as 100 over 10 divided by 2. So if somebody asks you, what is 100 divided by 10 divided by 2, you should tell them I don't know. Because either it can be 20, it can be 5. And I tried my best to make their division lines the same length. You know, notice that in this problem, that was the main division line, and that's where I put the equal sign. This divided by that equals 5. And if I ask you what's 10 divided, what's 20 divided by 4, you wouldn't write equals 5 or equals 5. Hopefully, you would write equals 5 like that. Notice here, this was the main division line. So I wrote equal right there. This number divided by that number equals 20. I wouldn't even know where to write the equal sign. Do I write the equal sign there? There's no reason it should be there. It's not the main division line. Same argument down here. I do not know what this is. I wouldn't even put an equal sign. I don't know what it is. So, understand that main division lines are very important. This fraction equal 2 over 15. Same three numbers, same order. 2, 3, 5. 2, 3, 5. I got different answers. They are not the same. So always pay attention to where the main division line is. And if you see nonsense like this, whoever wrote it, ask them, what did they mean? Do they mean 100 divided by 10 divided by 2? Or do they mean 100 divided by 10 divided by 2? Because these are different problems. Okay, that finishes the section on division of fractions.